When we have our data entered, the first thing we need to do is check it very carefully. So we need to look at the descriptive statistics that represent the data sets. Now we have two different experimental conditions here. We've got the quiet and the noisy. So we need to look at them separately. So this is how we do it. Click on Analyze, Descriptive Statistics, and you can use the descriptives, but you get more information if you click on Explore. So click on Explore. We put both of the columns that we want to look at into the dependent list. Click on the Plots button and select Histogram and unselect Stem and Leaf. I just find it more useful to have a histogram. Click on Continue and then click OK. When you do any type of analysis in SPSS, the results will appear in a separate output window. So this is what it looks like. So I'm just going to make a bit more space, pull this across a bit, and then scroll down. So this is the output that we get. As you can see, it's listed the two sets of data separately, so the quiet and the noisy. Gives us a summary, tells me how many cases there were. So these are the descriptives for the quiet RT, got the mean, the confidence intervals, the median, standard deviation, tells us what the minimum and maximum scores were, the range, which is just the difference between the minimum and maximum scores, the interquartile range, which tells us how far apart the middle 50% of the data lie, and we got information about skewness, that is whether the data are normally distributed or not, are they skewed to one side or the other, and kurtosis, which tells us about how narrow or flat the distribution is. So we've got that for the quiet condition, and then we've got it for the noisy condition as well. Now below this we have a histogram. First of all, the histogram for the quiet condition. It's all piled up on the left, and we have what looks like an outlier out here, someone that just seems to have taken much longer than everybody else to complete the tasks. And then we have a box and whisker plot. Now on the box and whisker plot, the thick black line in the middle represents the median of that data set. The box represents the interquartile range. So if you take the middle 50% of the data, this is the bottom of it and this is the top. So that's the interquartile range. These whiskers extend 1.5 times the interquartile range from the top of the box. So this point up here is 1.5 times the width of the box from the box, and this is 1.5 times the width of the box below the box. So it encapsulates the data that fall within those limits. Any data points that fall beyond that, so if they fall beyond 1.5 interquartile ranges beyond the top of the interquartile range, then they appear as outliers. So we've got 37 and 38. So these are the case numbers in the data set. So participant number 37 and participant number 38 seem to have taken an awful lot longer than everybody else when they did the quiet RT task. So I have the same again for the noisy RT. The histogram again is very skewed, it's all piled up at one end. We seem to have an outlier down here. Same thing again, only this time we can see it's case number 34 and case number 38 who seem to have taken a lot longer to deal with doing this task. So that tells us that we do have a problem here in that the data are not normally distributed. They don't all seem to have come from a normally distributed population. But it seems like that's mainly due to these people that have just taken a long time. So that's how we get the descriptive statistics for a within groups or repeated measures design.